Okay, we're going to start out talking about some basic definitions that are vital to understanding the rest of this geometry class. So, some basic, like I said, some basic shapes, some basic lines, points, angles, rays. We'll start with a point. A point is a location. It has no size and it has no shape. It is simply a spot. Always use capital letters to name points. Example, over here on the left, this is point. We can call it point A, or sometimes you can just put a dot with an A next to it. Point A or point A. The second definition, a line. A line is made up of points. So what you actually see when you see a line is a lot of points lined up next to each other, like this. And I don't like the way they word this, any 2 points define a line. Obviously, there are more than 2 points on this line, but if I give you 2 points and I say draw a line through those 2 points, there's only one line that you can draw through it. If I put a dot here and say draw a line, any 2 points define a line. So that what that means is with 2 points, there's only one line that can go through those 2 points. A line has no width or thickness. It's a lot like a point in that respect. How wide is this line? How tall is it? It has no width. It has no thickness. You name a line by any 2 points, and remember that 2 points define that line. So you can take any 2 points on that line, or you can use a lowercase script letter. Here's some examples. You can call this line XY since that's the only 2 points above it or on the line. Now above it, you need to actually draw a picture of a line. So that would be line XY. You could call it line N because the N, the lowercase n that's on it. Or you could just actually write out line XY. But it does have to actually have the symbol or the word in front of it. Some definitions that go along with a line. Collinear. Okay, I want to point out the word line in the middle of that, and then the prefix co. The prefix co means with or together. Okay, so if 2 points are collinear, they are together with each other on the same line. Points that lie on the same line are collinear. Here, X and Y are collinear. Non-collinear points, points that do not lie on the same line, must be at least 3 points in order to be non-collinear. Because if I say these 2 points are non-collinear, that's wrong because they lie on this line. However, if you have points in X and Y on this line, point Z right here would be non-collinear with those 2 points. Next up, a plane. A plane is simply a flat surface. And this flat surface is made up of tons and tons of points. Any 3 points will define a plane. So now this is very important that those 3 points must be non-collinear. So any 3 points define a plane. A plane extends indefinitely in all directions. So it goes forever in this direction, forever in this direction, in every direction. Now, however, you've got to be careful saying in all directions because this plane is flat. It doesn't go up in the air like this, okay? So it goes left, right, this direction, forwards, and backwards. A plane, again, extends indefinitely in all directions. Name a plane by any 3 non-collinear points on the plane or with an uppercase script letter. And we say script is like a cursive letter. So we could name this plane KJL. And again, we got to be super careful that those 3 points are not collinear. Or we could call this plane, and we could use that cursive letter, plane P, if you just want to make it cursive looking there. Again, coplanar now means that the points lie in the same plane. So here KJ and L would be coplanar. Non-coplanar, obviously there must be 4 points because if you have 3 points, they're going to be in the same plane or in a plane together. Planes that do not, or points that do not lie in the same plane. So if you have KJ and L and then somewhere down here below it, it's hard to draw it below it. If you have point M that's below that plane, then that point M would be non-coplanar. Intersecting lines and planes. Two lines will always intersect at a point if they have points of intersection. And two planes, if again these planes are going forever in each direction, so therefore where they cross will always go forever in this direction. So therefore two planes will intersect at a line. Okay, here we go. Let's get some practice. Let's name some points, lines, planes. It says use the diagram to the right to name the following 4 collinear points. And again, collinear means they're on the same line. So we want 4 points that are on the same line. Here are 4 right here, points H, N, K, and I. So there we go. A line that contains point M. So here's point M right here. The line that contains it is right here. And we can name this a couple of ways. You can name it line MN, MO, ON, OM. Any of those ways, any 2 points on that line would be fine. Now, C part says a line that contains point H and K, points H and K. So here's point H, here's point K. So this line right here contains both of them. And again, you can use any 2 letters. I'm going to use H and I with a line symbol above it. Another name for line Q. So here is line Q. So that's this line right here. So that'd be another name for it. Would be line JL. Again, you could use JK, KL, doesn't matter. The intersections of lines Q and R. So line Q and R cross right here at point K. Number 2, use the diagram at the right to answer the following. A line containing point F. So here's point F. So the line containing it is right here. So that would be line D, E, F, again, any 2 points. Another line, name for line K. Here is line K that goes up and down through this plane. We'll call that line BC, EC, BE, doesn't matter. So we'll call it BC. A plane containing point A, and here's point A. So there's only one plane that we can see here. So again, 3 non-collinear points. So you cannot name this plane DEF because those 3 points are collinear. So DAE, DAF, EAF, or plane M. Any of those would be fine because that cursive letter in the corner would also work. An example of 3 non-collinear points. So 3 points that are not in a straight line. We could do B and E are in a straight line, but let's throw in D because all 3 of those don't lie on the same line. And E part, the intersection of plane M and line K. Plane M, you can see it, flat surface right here, and then line K, it goes up and down. They cross right here at point E. Okay, number 3. Use the diagram at the right to name the following 3 coplanar points. And again, here we see several planes. We have the flat plane here, which is the bottom of this pyramid. We have the left side, which is a plane, the front's a plane, the right side's a plane, and the back side is a plane. And even though they aren't that plane shape, again, we could say they extend forever in all directions. They're still planes. 3 coplanar points. So we could say V, W, and X are in the same plane. We could also say W, X, and Z are in the same plane because you could run a flat surface through those 3 points. So any 3 points like that would work. And that is just 2 of many answers that you could give. A plane containing point X. So here's point X, and we've given one plane there. We could use WXZ. But let's go ahead and use this bottom plane, X, WV is also 3 non-collinear points, or we could just say plane R, since all 3 of those points are in plane R. The intersection of plane R and plane ZVY. And this is a little bit tougher to see, so I highlighted them. The red plane and the purple plane. The red plane, again, goes forever in all 4 of its directions. The purple plane as well goes forever. So this plane, it doesn't just stop right here. These planes continue on and in all directions. So therefore, the actual intersection, if you extend that purple and red plane, the actual intersection would be this line. So we're going to call it line VY. Okay, how many planes appear in this figure? And we kind of touched on that a while ago. You have the four sides of this pyramid are create planes, and then the bottom is also a plane. So I would say there are actually 5 planes in this figure that you can see. How many planes, how many of those planes contain point W? And that would be plane R at the bottom. You have this plane over here, which contains the right side, and you have the front, which is also contains that. So 3 of the 5 contain point W. Okay, number 4. Use diagram at the right to answer the following. The intersections of lines L and M. So line L and line M cross right here at point E. Another name for plane Q. Here you have plane Q, and again, we can use any 3 points in that plane as long as they are non-collinear. So we cannot use F, E, and G. However, we can use F, E, and I. Are points D and E collinear or coplanar? Let's find those points D and E. Here is D and here is E. They are definitely collinear, but here's the thing. They're also coplanar because if you're given 2 points, they have to lie in the same plane. You could draw a plane that passes through both of those points. However, you can't see it here, but if I were to draw a plane that looked like this, that kind of passed through those 2 points, it would also be coplanar. So therefore, they are both. Now, what you got to remember is the plane is not drawn there, but there is a plane that you could draw through those. How many times do planes P and Q intersect? And those planes P and Q look to be parallel planes, so they do not intersect. They intersect 0 times.